Do you know the history and quality of the top foods on your favorite food list? Today, we dive deep into the incredible, surprising, and absolutely fascinating world of sweet corn, a food that has shaped civilizations, fueled economies, and delighted taste buds for thousands of years. Please let us know in the comments where you are watching this history video and what time you are watching it. And be sure to subscribe to our channel for more history videos in the future. Now sit back, relax, and prepare yourself for a journey through time, science, culture, and flavor, a journey that begins thousands of years ago in a world very different from the one we know today. Sweet corn. You see it at summer cookouts, in grocery stores, on dinner tables, and at roadside stands. You have eaten it on the cob, slathered in butter and sprinkled with salt. You have scooped it from a can, warmed it in a pot, and served it alongside your favorite meals. It is one of the most beloved, most consumed, and most versatile foods on the planet. But how much do you really know about the golden grain that graces your plate? Most people think of sweet corn as just another vegetable. They see the bright yellow kernels, the green husk, the silky threads spilling out from the top, and they think nothing more of it. But sweet corn is far more than a simple side dish. It is a food with a story that stretches back millennia, crosses continents, and touches nearly every aspect of human civilization. Let us begin at the very beginning. Sweet corn, as we know it today, is a naturally occurring genetic mutation of field corn. Field corn, also known as dent corn, is the standard variety of maize that has been cultivated for thousands of years. Sweet corn differs from field corn in one crucial way. It carries a recessive gene that prevents the conversion of sugar into starch within the kernel. This single genetic difference is what gives sweet corn its characteristic sweetness, its tender texture, and its status as one of the most popular foods in the world. But the story of sweet corn does not begin with the mutation. It begins with maize itself. Maize, the parent plant of sweet corn, is one of the oldest cultivated crops in human history. Archaeological evidence suggests that maize was first domesticated from a wild grass called Teosinte. Teosinte is a plant that looks almost nothing like modern corn. It is a thin, weedy grass with tiny seed heads that bear only a handful of hard, nearly inedible kernels. The transformation from Teosinte to maize is one of the most remarkable feats of selective breeding in the history of agriculture. The domestication of maize began approximately 9,000 years ago. Some researchers place the date even earlier, suggesting that the process may have started as long as 10,000 years ago. The region where this domestication took place is believed to be the Balsas River Valley in what is now southern Mexico. There, ancient peoples began selecting Teosinte plants with larger seed heads, more kernels, and softer outer shells. Over hundreds and eventually thousands of generations, these selections gradually transformed the wild grass into the robust, high-yielding crop we recognize today. This was not a quick process. The transformation from Teosinte to maize took thousands of years of patient, deliberate cultivation. Each generation of farmers chose the best plants, saved the best seeds, and replanted them in their fields. Slowly, the tiny seed heads of Teosinte grew larger. The kernels became softer, more numerous, and more tightly packed on the cob. The plant itself grew taller, sturdier, and more productive. It was a masterwork of ancient agricultural science, carried out by people who had no understanding of genetics but an extraordinary intuition for selection and cultivation. By about 5,000 years ago, maize had become a staple crop across much of Mesoamerica. The Maya, the Aztec, and countless other civilizations built their societies around the cultivation of maize. It was not merely a food, it was a sacred plant, woven into the mythology, religion, and daily life of entire cultures. The Maya creation myth, recorded in the Popol Vuh, tells of the gods creating humanity from maize dough. For these ancient peoples, maize was life itself. As maize spread across the continents, it diversified into hundreds of distinct varieties. Some were bred for grinding into flour, others were bred for animal feed, some were popped over open flames as a snack, and some, through a twist of natural genetics, developed a sweetness that set them apart from all the rest. The exact moment when sweet corn first appeared in human agriculture is difficult to pinpoint. The mutation that causes sweetness in corn, the sugary gene, known to scientists as the SU gene, is a naturally occurring variation. It likely appeared multiple times throughout the history of maize cultivation. Whenever a plant carrying this gene produced ears with noticeably sweeter, more tender kernels, observant farmers would have taken note. The earliest recorded observations of sweet corn come from the indigenous peoples of the northern regions of the Western Hemisphere. Several native nations, including the Iroquois, cultivated varieties of corn that were notably sweeter than standard field corn. These sweet varieties were prized for their flavor and were often eaten fresh, directly off the cob, a practice that was uncommon with the harder, starchier field corn varieties. The Iroquois, in particular, played a crucial role in the early history of sweet corn. They are believed to have been among the first peoples to deliberately cultivate sweet corn as a distinct variety, separate from the field corn used for grinding and storage. Their sweet corn varieties were shared with European settlers in the late 1700s, marking the beginning of sweet corn's journey into the wider world. One of the earliest documented instances of sweet corn being shared with European settlers occurred in the year 1779. During a military expedition through Iroquois territory, soldiers encountered fields of sweet corn and collected samples. These samples were brought back to settled areas and planted, beginning the cultivation of sweet corn outside of its indigenous origins. From that point forward, sweet corn began to spread rapidly. Farmers recognized its unique qualities, the sweetness, the tenderness, the appeal of eating corn fresh rather than dried and ground, and began cultivating it with increasing enthusiasm. By the early 1800s, sweet corn had become a common garden crop in many regions. The first named variety of sweet corn to gain widespread popularity was called Nonesuch. It appeared in the early 1800s and quickly became a favorite among gardeners. Nonesuch was prized for its sweetness and its relatively large ears, and it set the stage for the explosion of sweet corn varieties that would follow in the decades to come. Another early variety was called Darling's Early, which appeared around 1844. This variety was notable for its early maturation, allowing farmers to harvest sweet corn earlier in the growing season. Early maturation became a highly desirable trait in sweet corn breeding, as it extended the window of time during which fresh sweet corn was available. As sweet corn grew in popularity, plant breeders began working to improve it. They selected for larger ears, more rows of kernels, greater sweetness, better disease resistance, and longer shelf life. The history of sweet corn breeding is a story of relentless improvement, driven by the simple desire to make an already delicious food even better. One of the most important developments in sweet corn breeding occurred in the 1950s, when researchers discovered the shrunken 2 gene, commonly abbreviated as SH2. This gene, when present in corn, dramatically increases the sugar content of the kernels, sometimes by as much as 4 to 10 times compared to standard sweet corn varieties. Corn carrying the SH2 gene became known as Supersweet corn, and it revolutionized the sweet corn industry. Supersweet corn had advantages beyond just its flavor. Because the kernels contained so much sugar, they converted to starch more slowly after harvest. This meant that Supersweet corn stayed sweet longer, giving farmers and distributors more time to get the corn from the field to the consumer. This extended shelf life was a game changer for the commercial sweet corn industry, but Supersweet corn also had its drawbacks. The kernels were smaller and more fragile than those of traditional sweet corn. The plants were often less vigorous and more susceptible to certain diseases. And some consumers felt that the extreme sweetness of SH2 varieties was actually too much, that it overwhelmed the subtle, complex corn flavor that they loved about traditional sweet corn. In response to these concerns, breeders developed yet another category of sweet corn, the sugar-enhanced varieties, carrying the C gene. Sugar-enhanced sweet corn offered a middle ground between traditional sweet corn and supersweet varieties. It was sweeter than standard sweet corn, but not as intensely sweet as supersweet. The kernels were tender and creamy, with a more traditional corn flavor, and the plants were generally more vigorous and easier to grow than supersweet varieties. Today, the sweet corn market is dominated by three main genetic types: standard sugary, sugar-enhanced, and supersweet, along with various hybrids that combine traits from two or more of these types. The diversity of sweet corn varieties available to modern farmers and gardeners is staggering. There are yellow varieties, white varieties, and bicolor varieties with both yellow and white kernels on the same ear. There are early season varieties, mid-season varieties, and late season varieties. There are varieties bred for fresh eating, varieties bred for canning, and varieties bred for freezing. The journey from Teosinte to this incredible diversity of sweet corn is one of the great stories of human agriculture. It is a testament to the ingenuity, patience, and determination of countless generations of farmers and breeders who saw the potential in a humble grass and transformed it into one of the most important and beloved foods on earth. Now, let us talk about how sweet corn grows. Sweet corn is a warm season crop. It thrives in heat and sunshine and cannot tolerate frost. The ideal soil temperature for planting sweet corn is at least 60 degrees Fahrenheit, and the plants grow best when daytime temperatures are between 75 and 95 degrees Fahrenheit. Sweet corn is typically planted in the spring after the last frost has passed and is harvested in the summer or early fall, depending on the variety and the climate. A single sweet corn seed, when planted in warm, moist soil, will germinate within 7 to 14 days. The seedling pushes through the soil surface and begins to grow rapidly, driven by the abundant energy stored in the seed. Within a few weeks, the young plant develops a strong root system and a sturdy stalk, and it begins producing the long, narrow leaves that are characteristic of all corn plants. Sweet corn is a member of the grass family Poaceae. Like all grasses, it is a monocot, a plant with a single seed leaf, parallel leaf veins, and a fibrous root system. But unlike most grasses, sweet corn grows remarkably tall. A mature sweet corn plant can reach heights of 6 to 10 feet or more, depending on the variety and growing conditions. The stalk of a sweet corn plant is thick and sturdy, divided into segments by nodes. At each node, a leaf emerges, wrapping tightly around the stalk before extending outward. The leaves of a sweet corn plant can be quite large, sometimes reaching 3 feet in length and 4 inches in width. These broad leaves are highly efficient at capturing sunlight, which the plant uses to produce the sugars that will eventually fill its kernels. Sweet corn is a monoecious plant, meaning that each individual plant produces both male and female flowers. The male flowers are located at the very top of the plant in a structure called the tassel. The tassel produces vast quantities of pollen. A single tassel can release millions of pollen grains over the course of several days. This pollen is carried by the wind to the female flowers of neighboring plants. The female flowers of a sweet corn plant are located lower on the stalk, enclosed within the developing ears. Each ear is wrapped in layers of modified leaves called husks, and from the tip of each ear, a bundle of long, slender threads emerges. These threads are called silks, and each individual silk is connected to a single potential kernel on the ear. For a kernel to develop, a pollen grain must land on its corresponding silk. The pollen grain then sends a pollen tube down through the silk to fertilize the ovule at its base. If pollination is successful, the ovule develops into a plump, juicy kernel. If not, the kernel remains undeveloped, leaving a gap on the ear. This is why sweet corn is typically planted in blocks rather than in single rows. Block planting increases the chances that wind-borne pollen from the tassels will land on the silks of neighboring plants, ensuring thorough pollination and full, well-filled ears. A typical sweet corn ear contains anywhere from 400 to 800 individual kernels, arranged in rows that spiral around the cob. The number of rows is always even, a quirk of corn biology that has fascinated scientists and curious gardeners alike. Most sweet corn ears have between 12 and 20 rows of kernels, though some varieties may have more or fewer. The color of sweet corn kernels is determined by genetics. The most common color is yellow, which is produced by carotenoid pigments in the kernel. White kernels lack these pigments and appear pale or creamy. Bicolor varieties produce ears with a mix of yellow and white kernels, creating a striking and attractive appearance. After pollination, the kernels begin to fill with sugars. In field corn, these sugars are quickly converted to starch, resulting in hard, dense kernels that are suitable for grinding but not for fresh eating. In sweet corn, however, the genetic mutations we discussed earlier, the SU, C, and SH2 genes, slow or prevent this conversion, allowing the kernels to remain sweet and tender. The timing of the harvest is critical for sweet corn. The kernels are at their sweetest and most tender during a brief window known as the milk stage, when the kernels are plump and full of sweet, milky liquid. If harvested too early, the kernels are watery and underdeveloped. If harvested too late, the sugars begin to convert to starch and the kernels become tough and starchy. For traditional SU varieties, this window of peak sweetness can be as brief as 24 to 48 hours. For sugar-enhanced and supersweet varieties, the window is somewhat longer, but timing is still important. Once harvested, sweet corn begins to lose its sweetness almost immediately. In traditional varieties, the sugar-to-starch conversion accelerates rapidly after the ear is picked. This is why fresh sweet corn is always best when eaten as soon as possible after harvest. There's an old saying among corn lovers, "Put the water on to boil before you go out to pick the corn." This advice reflects the importance of minimizing the time between harvest and consumption. Modern supersweet varieties have alleviated this problem somewhat, as their higher sugar content and slower conversion rate give them a longer post-harvest shelf life. But even with these improved varieties, fresh sweet corn is always at its best when it is truly fresh. Now let us explore the nutritional profile of sweet corn and understand why it is not only delicious but also genuinely good for you. Sweet corn is a surprisingly nutritious food. A single ear of sweet corn contains a moderate number of calories, making it a satisfying but not overly heavy food. The majority of those calories come from carbohydrates, primarily in the form of natural sugars and some starch. Sweet corn also contains a modest amount of protein and a small amount of fat. One of the most notable nutritional features of sweet corn is its fiber content. Sweet corn is a good source of dietary fiber, which is essential for healthy digestion. Fiber helps to regulate bowel movements, prevent constipation, and maintain a healthy gut microbiome. The fiber in sweet corn is a mix of soluble and insoluble types, both of which play important roles in digestive health. Sweet corn is also a good source of several important vitamins. It contains significant amounts of vitamin C, an antioxidant that supports immune function, skin health, and wound healing. It provides B vitamins, including thiamine, which is essential for energy metabolism, and folate, which is crucial for cell division and is especially important during pregnancy. Sweet corn also contains vitamin A, primarily in the form of beta-carotene, the pigment that gives yellow kernels their color. In terms of minerals, sweet corn provides potassium, which is important for maintaining healthy blood pressure and proper muscle and nerve function. It also contains magnesium, which plays a role in hundreds of biochemical reactions in the body, including energy production, muscle contraction, and nerve signaling. Phosphorus, another mineral found in sweet corn, is essential for healthy bones and teeth and for the proper functioning of cells. Sweet corn contains several powerful antioxidants that have been the subject of considerable scientific interest. Lutein and zeaxanthin, two carotenoid pigments found in yellow sweet corn, are particularly noteworthy. These antioxidants accumulate in the retina of the eye, where they help to filter harmful blue light and protect against age-related macular degeneration, a leading cause of vision loss in older adults. Regular consumption of foods rich in lutein and zeaxanthin has been associated with a reduced risk of this debilitating condition. Another antioxidant found in sweet corn is ferulic acid. Ferulic acid is a phenolic compound with potent anti-inflammatory and antioxidant properties. Research has shown that ferulic acid can help neutralize harmful free radicals in the body, reducing oxidative stress and potentially lowering the risk of chronic diseases such as heart disease and certain cancers. Sweet corn also contains phytosterols, plant-based compounds that have a structure similar to cholesterol. Phytosterols have been shown to help lower blood cholesterol levels by competing with cholesterol for absorption in the digestive tract. Regular consumption of foods containing phytosterols, including sweet corn, may contribute to improved cardiovascular health. The protein in sweet corn, while not as complete as the protein found in animal products, does contain several essential amino acids. When combined with other protein sources, such as beans or legumes, corn protein can contribute to a complete and balanced amino acid profile. This complementary protein combination has been a dietary staple for many traditional cultures for thousands of years. Sweet corn is naturally gluten-free, making it a safe and delicious option for individuals with celiac disease or gluten sensitivity. This characteristic has made corn-based products increasingly popular in the growing market for gluten-free foods. It is worth noting that the nutritional content of sweet corn can vary depending on how it is prepared. Boiling sweet corn in water can cause some water-soluble vitamins, such as vitamin C and certain B vitamins, to leach out into the cooking water. Steaming or microwaving sweet corn tends to preserve more of these nutrients. Grilling sweet corn, a popular cooking method, can actually enhance the availability of certain antioxidants, as the heat breaks down cell walls and releases compounds that would otherwise be less accessible. Adding butter or oil to sweet corn, while it increases the calorie content, can actually enhance the absorption of fat-soluble vitamins and antioxidants, such as beta-carotene, lutein, and zeaxanthin. So that pat of butter on your corn on the cob is not just delicious, it may actually help your body make better use of the nutrients in the corn. Now, let us delve into the many ways that sweet corn has been prepared and enjoyed throughout history and across cultures. The simplest and perhaps the most ancient way to eat sweet corn is straight off the cob. Long before the invention of modern cooking methods, people ate sweet corn by simply peeling back the husk and biting into the raw kernels. Raw sweet corn, when it is truly fresh and at the peak of its sweetness, is a remarkable treat, crisp, juicy, and bursting with flavor. Many corn enthusiasts argue that the very best way to eat sweet corn is raw, picked moments earlier from the stalk, but most people prefer their sweet corn cooked, and the methods for cooking sweet corn are nearly as varied as the people who eat it. Boiling is one of the most common and traditional methods of cooking sweet corn. The ears are shucked, that is, the husks and silks are removed and placed in a pot of boiling water. Cooking times vary, but most experts recommend boiling sweet corn for no more than 3 to 5 minutes. Overcooking can cause the kernels to become tough and can diminish the sweetness of the corn. There is an ongoing debate among corn lovers about whether to add salt to the boiling water. Some insist that salt toughens the kernels and should never be added to the cooking water. Others argue that a small amount of salt enhances the flavor without noticeably affecting the texture. Some cooks add a splash of milk or a spoonful of sugar to the boiling water, claiming that these additions help to preserve the sweetness and tenderness of the corn. The truth is that with truly fresh, high-quality sweet corn, none of these additions are necessary. The corn's own natural sweetness and tenderness are more than sufficient. Grilling is another beloved method of cooking sweet corn, and it produces a distinctly different flavor and texture. When sweet corn is grilled, the high heat caramelizes the natural sugars in the kernels, creating a rich, smoky sweetness that is utterly irresistible. Sweet corn can be grilled with the husks on, which steams the kernels inside their natural wrapper, or with the husks removed, which allows the kernels to char slightly and develop that characteristic grilled flavor. Roasting sweet corn over an open fire is a method that dates back thousands of years. Indigenous peoples across the Western Hemisphere roasted corn over coals and open flames long before the arrival of Europeans. This ancient cooking method remains popular today, particularly at fairs, festivals, and outdoor gatherings, where the aroma of roasting corn is one of the great sensory delights. Steaming is a gentler cooking method that preserves more of the corn's natural nutrients and delicate flavor. Sweet corn can be steamed in a standard steamer basket or in the microwave. Microwave cooking, in which the ears are placed in the microwave with their husks still on and cooked for a few minutes, has become an increasingly popular method due to its speed and convenience. The husks act as a natural steam wrapper, trapping moisture and cooking the kernels evenly. Beyond these basic cooking methods, sweet corn has been incorporated into an astonishing variety of dishes across cultures and cuisines. Corn chowder is a classic dish that showcases the natural sweetness and creamy texture of sweet corn. This thick, hearty soup typically combines corn kernels with potatoes, onions, cream, and seasonings. It has been a beloved comfort food for centuries, and variations of corn chowder can be found in cookbooks dating back to the 1800s. Corn pudding is another traditional dish that highlights the versatility of sweet corn. This custard-like dish combines corn kernels with eggs, milk, butter, and sugar, and is baked until set. Corn pudding has deep roots in the culinary traditions of many regions and is often served as a side dish at holiday meals and special occasions. Succotash is a dish with ancient origins, combining corn kernels with lima beans and often other vegetables. The word succotash is derived from the Narragansett word emsiquitash, meaning boiled corn kernels. This dish was a staple of native cuisine and was adopted by European settlers who added their own variations. Today, succotash remains a popular side dish, particularly in the southern and eastern regions. Corn fritters, small, deep-fried cakes made from a batter of corn kernels, flour, and eggs, are a beloved snack and side dish. They are crispy on the outside, tender and sweet on the inside, and are often served with butter, maple syrup, or a dusting of powdered sugar. Corn salsa, a fresh and vibrant combination of sweet corn kernels, tomatoes, onions, peppers, cilantro, and lime juice, has become a popular condiment and snack food. The sweetness of the corn pairs beautifully with the acidity of the tomatoes and lime, creating a balanced and refreshing flavor profile. Creamed corn is a preparation in which sweet corn kernels are cooked in a mixture of cream, butter, and seasonings until the mixture is thick and luscious. This dish is a classic side at family dinners and is also one of the most popular forms of canned corn. Corn on the cob, served simply with butter and salt, remains the quintessential way to enjoy sweet corn. There is something deeply satisfying about sinking your teeth into a perfectly cooked ear of corn, feeling the kernels pop and release their sweet juice. It is a primal eating experience that connects us to the thousands of years of human history that have been shaped by this remarkable plant. In many Latin cultures, corn on the cob is prepared in distinctive and delicious ways. Elote, a popular street food, features grilled corn on the cob slathered with mayonnaise, sprinkled with chili powder and cotija cheese, and finished with a squeeze of lime. The combination of sweet, creamy, spicy, and tangy flavors makes elote one of the most addictive street foods on the planet. Esquites, a related dish, features the same flavors as elote but with the kernels cut off the cob and served in a cup. This makes it easier to eat on the go and allows the seasonings and toppings to be more evenly distributed throughout the corn. In many Asian cuisines, sweet corn has been embraced with enthusiasm and creativity. In parts of East Asia, sweet corn is a popular pizza topping, a combination that may surprise some Western palates but is beloved by millions. Sweet corn is also used in soups, stir-fries, tempura, and even desserts in various Asian culinary traditions. Sweet corn ice cream and sweet corn cake are popular treats in several Southeast Asian countries, where the natural sweetness of corn lends itself beautifully to dessert applications. In some regions, sweet corn is combined with coconut milk and sugar to create a warm, comforting pudding. In parts of Africa, corn has been a dietary staple for centuries, and sweet corn is enjoyed both fresh and in various prepared dishes. Grilled corn on the cob is a common street food in many African countries, often seasoned with spices and served with a squeeze of citrus. The versatility of sweet corn in the kitchen is truly remarkable. It can be the star of the show or a supporting player. It can be sweet or savory, simple or complex, rustic or refined. It adapts to virtually any cuisine and any cooking method, and it never fails to delight. Now let us turn our attention to the agricultural side of sweet corn, how it is grown on a commercial scale, and the challenges that farmers face in bringing this beloved crop from the field to the table. Sweet corn is grown commercially in many countries around the world, but some regions have become particularly well known for their sweet corn production. In the Western Hemisphere, sweet corn is a major crop in several states and provinces with warm summers and fertile soils. The combination of heat, sunshine, and rich agricultural land creates ideal conditions for sweet corn cultivation. The commercial sweet corn growing season typically begins in the spring, when soil temperatures have warmed sufficiently for seed germination. Farmers prepare their fields by plowing, disking, and smoothing the soil to create a fine, even seed bed. Sweet corn seeds are planted using mechanical planters that space the seeds at precise intervals, ensuring optimal plant density. The typical planting rate is approximately 24,000 to 32,000 seeds per acre, depending on the variety and the intended use of the crop. After planting, farmers must manage a variety of challenges to bring their crop to a successful harvest. Weed control is one of the most important early season tasks. Weeds compete with young corn plants for sunlight, water, and nutrients, and if left unchecked, they can dramatically reduce yields. Farmers use a combination of mechanical cultivation and herbicide applications to keep weeds in check. Insect pests are another major concern for sweet corn growers. The corn earworm is one of the most destructive pests of sweet corn. The adult moth lays its eggs on the silks of the developing ears, and the larvae burrow into the ear, feeding on the kernels and leaving behind unsightly damage and frass. Other insect pests of sweet corn include the European corn borer, the fall armyworm, the corn flea beetle, and various species of aphids. Managing these pests requires a combination of strategies, including the use of insecticides, the planting of pest-resistant varieties, and the implementation of integrated pest management practices that aim to minimize the use of chemicals while still protecting the crop. Disease is another challenge that sweet corn growers must contend with. Common diseases of sweet corn include Stewart's wilt, a bacterial disease spread by corn flea beetles, northern cornleaf blight, a fungal disease that causes large, grayish-green lesions on the leaves, and common rust, which produces small, reddish-brown pustules on the leaf surfaces. These and other diseases can reduce yields and affect the quality of the harvested ears. Irrigation is often necessary for commercial sweet corn production, particularly in regions with irregular rainfall. Sweet corn requires a consistent supply of moisture throughout its growing season, and even brief periods of drought stress can reduce yields and affect kernel quality. The critical period for water is during tasseling and silking, when the plants are pollinating and the kernels are beginning to fill. Drought stress during this period can result in poor pollination and poorly filled ears. The harvest of sweet corn is a time-sensitive operation. As we discussed earlier, sweet corn kernels are at their peak sweetness and tenderness for only a brief window of time. Commercial growers must monitor their fields carefully and harvest at precisely the right moment. For fresh market sweet corn, that is, corn destined to be sold as whole ears, the harvest is often done by hand. Workers walk through the fields, selecting ears that are at the proper stage of maturity, snapping them from the stalks and placing them in bins or wagons. Mechanical harvesting is used for sweet corn destined for canning or freezing. Specialized harvesting machines move through the fields, stripping the ears from the stalks and conveying them into trucks for transport to processing facilities. These machines can harvest several acres per hour, but they are less selective than hand harvesting and may include ears that are over or under mature. After harvest, sweet corn for the fresh market is quickly cooled to slow the conversion of sugars to starch and to preserve freshness. Hydrocooling, immersing the ears in ice-cold water, is a common method. Vacuum cooling and forced air cooling are also used. The goal is to reduce the temperature of the ears as quickly as possible, ideally to 32 to 35 degrees Fahrenheit, and to maintain that temperature throughout the distribution chain. For processing, sweet corn is transported to canning or freezing facilities, where it is husked, cleaned, and blanched. Blanching involves briefly immersing the ears in boiling water or steam to inactivate enzymes that would otherwise cause the corn to deteriorate in color, flavor, and nutritional value during storage. After blanching, the kernels are cut from the cob using high-speed cutting machines. The cut kernels are then either canned or frozen. Canned sweet corn has been a pantry staple for well over a century. The canning process involves placing the corn kernels in cans, adding a liquid medium, usually water with a small amount of salt and sometimes sugar, and then sealing and heating the cans to destroy any bacteria and create a sterile, shelf-stable product. Canned sweet corn can be stored at room temperature for years without spoiling, making it an incredibly convenient and economical food. Frozen sweet corn is another popular processed form. After blanching and cutting, the kernels are quickly frozen using blast freezers or individually quick frozen technology. Freezing preserves the flavor, texture, and nutritional value of the corn more effectively than canning, and many consumers prefer the taste and texture of frozen sweet corn to canned. The sweet corn industry is a massive enterprise. Millions of acres are planted to sweet corn each year worldwide, and the crop generates billions of dollars in economic value. Sweet corn is one of the most popular vegetables, consistently ranking among the top vegetables consumed per capita. But the story of sweet corn is not just about big farms and big business. Sweet corn is also one of the most popular crops for home gardeners. There's something deeply satisfying about growing your own sweet corn, watching the tiny seeds sprout, tending the growing plants, and finally harvesting your own ears of corn, still warm from the sun. Many gardeners consider homegrown sweet corn to be the ultimate reward of the garden, and they are not wrong. There is simply nothing that compares to the flavor of sweet corn picked minutes before it is eaten. Growing sweet corn in the home garden requires some space, as corn is wind-pollinated and must be planted in blocks to ensure proper pollination. A minimum block of 4 rows is generally recommended. The soil should be well drained and rich in organic matter, and the plants should receive full sunlight for most of the day. Home gardeners have access to an incredible variety of sweet corn seeds. Seed catalogs and garden centers offer dozens of varieties, ranging from classic heirlooms to the latest hybrids. Some popular varieties for home gardens include Silver Queen, a white variety known for its exceptional sweetness and tenderness; Peaches and Cream, a bicolor variety with a beautiful mix of yellow and white kernels; Honey Select, a sugar-enhanced variety with outstanding flavor; and Elote Extra Sweet, one of the original Supersweet varieties. Heirloom sweet corn varieties have a dedicated following among gardeners who value historical authenticity and unique flavors. Varieties like Stowell's Evergreen, which dates back to 1848, and Golden Bantam, which was introduced in 1902, offer a connection to the past and flavors that are distinct from modern hybrids. Golden Bantam in particular holds a special place in the history of sweet corn. Before its introduction, most sweet corn varieties had white kernels. Golden Bantam was one of the first yellow sweet corn varieties to gain widespread popularity, and it helped to establish yellow corn as the standard for sweet corn in many regions. Country Gentleman is another beloved heirloom variety, notable for its irregular arrangement of kernels on the cob. Unlike most corn varieties, which have their kernels arranged in neat, even rows, Country Gentleman has kernels that are scattered irregularly across the surface of the cob. This unusual arrangement is purely aesthetic. The flavor of Country Gentleman is superb, with a rich, old-fashioned corn taste that modern hybrids sometimes lack. The diversity of sweet corn varieties extends beyond flavor and color. Some varieties have been bred for specific uses or growing conditions. There are varieties bred for short-season growing areas where the frost-free period is brief and the summer is cool. There are varieties bred for resistance to specific diseases or pests. There are varieties bred for exceptional performance in containers or small gardens, and there are varieties bred specifically for the canning or freezing industry, optimized for processing rather than fresh eating. Let us now explore some of the more surprising and lesser-known aspects of sweet corn. Did you know that sweet corn is technically a grain, not a vegetable? Botanically speaking, corn is a cereal grain, a member of the grass family that produces edible seeds. However, because sweet corn is harvested and eaten when the kernels are still immature and tender, it is classified as a vegetable for culinary and nutritional purposes. This dual identity, grain and vegetable, makes sweet corn unique among commonly eaten foods. The silk of a sweet corn ear, those long, slender threads that emerge from the top of the husk, is not just a functional part of the plant. Corn silk has been used in traditional medicine for centuries. Herbalists have long prescribed corn silk tea as a remedy for urinary tract infections, kidney stones, and inflammation of the bladder. Modern research has confirmed that corn silk contains compounds with diuretic, anti-inflammatory, and antioxidant properties, lending some scientific support to these traditional uses. Sweet corn cobs, the hard central core of the ear from which the kernels grow, have also found a variety of uses beyond the dinner table. In the past, dried corn cobs were used as fuel, as scrubbing tools, and even as a primitive form of toilet paper. Today, ground corn cob material is used as an abrasive in industrial cleaning applications, as a component of animal bedding, and as a biodegradable filler in various products. The husks of sweet corn, the green, leafy outer covering of the ear, have their own history of use. In many Latin cultures, corn husks are used as wrappers for tamales, a traditional dish of seasoned meat or other fillings enclosed in corn dough and steamed. Corn husks have also been used to make dolls, crafts, and decorative items. Sweet corn has even found its way into the world of beverages. Corn-based beverages, including chicha, a traditional fermented drink made from corn, have been consumed in parts of South and Central regions for thousands of years. In modern times, sweet corn has been used as an ingredient in smoothies, milkshakes, and even cocktails, where its natural sweetness adds a unique and unexpected dimension. Let us take a moment to discuss the environmental aspects of sweet corn production. Sweet corn, like all crops, has an environmental footprint. The cultivation of sweet corn requires land, water, energy, and various inputs such as fertilizers and pesticides. The environmental impact of sweet corn production depends on a variety of factors, including the farming practices used, the climate and soil conditions of the growing region, and the scale of production. One of the most significant environmental considerations in sweet corn production is the use of nitrogen fertilizer. Corn is a heavy feeder. It requires substantial amounts of nitrogen to produce high yields. The production and application of nitrogen fertilizer is energy-intensive and can contribute to greenhouse gas emissions. Additionally, excess nitrogen that is not taken up by the plants can leach into groundwater or run off into surface waters, contributing to water pollution and problems such as algal blooms and dead zones in coastal waters. However, there are many practices that sweet corn growers can adopt to minimize their environmental impact. Cover cropping, crop rotation, reduced tillage, and precision agriculture techniques can all help to improve soil health, reduce erosion, conserve water, and minimize the use of chemicals. Many farmers are increasingly adopting these sustainable practices, driven both by environmental concern and by the economic benefits of healthier, more productive soils. Organic sweet corn production has grown significantly in recent years, reflecting increasing consumer demand for foods grown without synthetic pesticides and fertilizers. Organic sweet corn growers rely on natural pest control methods, organic fertilizers such as compost and manure, and careful crop management to produce their crops. While organic sweet corn may yield somewhat less than conventionally grown sweet corn, many consumers are willing to pay a premium for the perceived environmental and health benefits of organic production. The water footprint of sweet corn is another important consideration. Sweet corn requires moderate amounts of water, less than some crops, such as rice, but more than others, such as wheat. In regions where water is scarce, the irrigation of sweet corn can place significant demands on water resources. Drip irrigation and other efficient irrigation technologies can help to reduce water use while still providing the moisture that sweet corn needs to thrive. Sweet corn production also supports biodiversity in certain ways. Cornfields can provide habitat for various species of birds, insects, and small mammals. The residues left in the field after harvest, stalks, leaves, and roots, return organic matter to the soil and provide food and shelter for soil organisms. However, large-scale monoculture corn production can also reduce biodiversity by replacing diverse natural habitats with uniform fields of a single crop. Now, let us explore some of the cultural and social dimensions of sweet corn. Sweet corn holds a special place in the cultural landscape of many regions. It is associated with summer, with outdoor cooking, with family gatherings, and with a certain nostalgic ideal of rural life. The image of a cornfield stretching to the horizon under a blue summer sky is one of the most iconic and evocative images in agricultural culture. Sweet corn festivals and corn roasts are popular events in many communities, bringing people together to celebrate the harvest and enjoy fresh corn in all its glory. These events often feature corn eating contests, corn cooking demonstrations, live music, and other festivities. They are a testament to the deep affection that people have for this simple, delicious food. The corn maze, a labyrinth cut into a field of standing corn, has become a popular autumn attraction in many regions. While corn mazes are typically made from field corn rather than sweet corn, they reflect the broader cultural significance of corn and its ability to bring people together for fun and community. Sweet corn has also made its mark in the world of competitive eating. Corn eating contests, in which participants race to consume as many ears of corn as possible in a set time period, are a popular spectacle at fairs and festivals. These contests are a light-hearted celebration of the joy of eating corn and the communal spirit of the harvest season. In the realm of art and literature, corn has been a recurring motif for centuries. Paintings, poems, novels, and songs have all drawn on the imagery of corn to evoke themes of abundance, fertility, nourishment, and the rhythms of agricultural life. The cornfield is a powerful symbol of hard work, of the connection between people and the land, and of the simple pleasures of a life lived close to nature. Let us now turn to some of the scientific research that has been conducted on sweet corn and its effects on human health. Research has shown that the antioxidants in sweet corn may help to reduce the risk of several chronic diseases. The carotenoids lutein and zeaxanthin, as we mentioned earlier, are associated with a reduced risk of age-related macular degeneration. But these compounds may also have broader health benefits. Some studies suggest that carotenoids may help to reduce the risk of certain cancers, including lung and breast cancer, by neutralizing free radicals and reducing oxidative damage to cells. The fiber in sweet corn has been extensively studied for its effects on digestive health. Research has consistently shown that dietary fiber promotes regular bowel movements, helps to prevent constipation, and supports the growth of beneficial bacteria in the gut. A healthy gut microbiome is increasingly recognized as important for overall health, influencing everything from immune function to mental health. Some studies have examined the potential role of sweet corn in weight management. Because sweet corn is relatively low in calories but high in fiber, it can help to promote feelings of fullness and satiety, potentially reducing overall calorie intake. The fiber in sweet corn slows the digestion and absorption of food, helping to stabilize blood sugar levels and prevent the spikes and crashes that can lead to overeating. The B vitamins in sweet corn, particularly thiamine and folate, play essential roles in energy metabolism and cell function. Thiamine is necessary for the conversion of carbohydrates into energy, and a deficiency in thiamine can lead to fatigue, weakness, and neurological problems. Folate is crucial for the synthesis of DNA and for proper cell division. An adequate folate intake is especially important during pregnancy to prevent neural tube defects in the developing fetus. Research has also explored the potential anti-inflammatory properties of sweet corn. Chronic inflammation is a contributing factor in many diseases, including heart disease, diabetes, and cancer. The phenolic compounds in sweet corn, including ferulic acid, have been shown to possess anti-inflammatory activity in laboratory studies, suggesting that regular consumption of sweet corn may help to reduce chronic inflammation. The resistant starch in sweet corn is another area of scientific interest. Resistant starch is a type of starch that is not digested in the small intestine, but instead passes into the large intestine, where it is fermented by gut bacteria. This fermentation produces short-chain fatty acids, which have been shown to have numerous health benefits, including improved gut barrier function, reduced inflammation, and enhanced insulin sensitivity. It is important to note, however, that sweet corn is not without its potential drawbacks, and a balanced view of this food requires an honest assessment of its limitations. One concern that is sometimes raised about sweet corn is its glycemic index. The glycemic index is a measure of how quickly a food raises blood sugar levels after it is eaten. Sweet corn has a moderate glycemic index, meaning that it can cause a moderate rise in blood sugar levels. For most healthy individuals, this is not a significant concern. However, for individuals with diabetes or insulin resistance, the glycemic impact of sweet corn may need to be considered in the context of their overall diet. Another concern relates to the use of genetically modified organisms, or GMOs, in corn production. A significant proportion of the corn grown worldwide is genetically modified, primarily for traits such as insect resistance and herbicide tolerance. While the scientific consensus is that approved GMO foods are safe for human consumption, some consumers prefer to avoid GMO foods for personal, ethical, or environmental reasons. For these individuals, choosing organic sweet corn, which is by definition non-GMO, is an option. Pesticide residues are another concern for some consumers. Conventionally grown sweet corn may be treated with various pesticides during its cultivation, and traces of these chemicals may remain on the harvested ears. However, sweet corn is generally considered to be one of the lower-risk foods in terms of pesticide residues, as the thick husk provides a natural barrier that helps to protect the kernels from direct pesticide contact. Washing and cooking sweet corn can further reduce any residual pesticides. Some individuals may experience digestive discomfort after eating sweet corn. The outer hull of the corn kernel is made of cellulose, a type of fiber that the human digestive system cannot break down. This is why you sometimes see intact corn kernels in your stool after eating corn. The cellulose hull passes through the digestive tract undigested. For most people, this is harmless and simply a reflection of the indigestible nature of cellulose. However, for individuals with sensitive digestive systems or conditions such as irritable bowel syndrome, the cellulose in corn may contribute to bloating, gas, or other discomfort. Corn allergies, while relatively rare, do exist. Some individuals may experience allergic reactions to proteins found in corn, with symptoms ranging from mild, such as hives, itching, or digestive upset, to severe, including anaphylaxis in very rare cases. Individuals with a known corn allergy must avoid sweet corn and all corn-derived products. There is also the issue of phytic acid in sweet corn. Phytic acid is a naturally occurring compound found in many grains and seeds, including corn. Phytic acid can bind to minerals such as iron, zinc, and calcium in the digestive tract, reducing their absorption. This is primarily a concern for individuals who rely heavily on corn as a staple food and who may not have access to a varied diet. For individuals who eat a diverse diet with multiple sources of minerals, the phytic acid in sweet corn is unlikely to cause significant nutritional deficiencies. Now let us discuss the economics of sweet corn. Sweet corn is a high-value crop compared to field corn. While field corn is primarily grown for animal feed, ethanol production, and industrial uses, and is sold at commodity prices, sweet corn commands a premium because it is grown for direct human consumption. Fresh market sweet corn in particular can be quite profitable for farmers, especially those who sell directly to consumers through farm stands, farmers markets, and community-supported agriculture programs. The sweet corn processing industry, encompassing both canning and freezing, is a major economic force. Processing companies contract with farmers to grow sweet corn, specifying the varieties, planting dates, and management practices. The harvested corn is transported to processing plants, where it is cleaned, processed, packaged, and distributed to retail outlets and food service operations around the world. The economics of sweet corn production are influenced by a variety of factors, including input costs, yield levels, market prices, weather conditions, and competition from other crops. Sweet corn is a relatively expensive crop to grow, requiring significant investments in seed, fertilizer, pest management, irrigation, and labor. However, the higher prices that sweet corn commands can more than offset these costs, making it an attractive option for many farmers. The labor requirements of sweet corn production are particularly notable. Fresh market sweet corn is often harvested by hand, a labor-intensive process that requires skilled workers who can identify ears at the proper stage of maturity. In many regions, the availability and cost of harvest labor are significant concerns for sweet corn growers. Sweet corn is a perishable commodity, and the logistics of getting it from the field to the consumer in peak condition are complex and demanding. Cold chain management, maintaining the proper temperature from harvest through distribution to the point of sale, is essential for preserving the quality of fresh sweet corn. Any break in the cold chain can result in a rapid loss of sweetness and freshness, reducing the value and appeal of the product. The retail price of sweet corn varies widely depending on the time of year, the region, and the source. During the peak of the local growing season, fresh sweet corn is often abundant and affordable, with prices that make it one of the best values in the produce aisle. Out of season, fresh sweet corn must be shipped from distant growing regions, and the price typically increases to reflect the higher transportation costs. Canned and frozen sweet corn are available year-round at relatively stable prices, providing a convenient and economical alternative to fresh. Let us now explore the role of sweet corn in global food systems and food security. Maize, the parent crop of sweet corn, is one of the three most important cereal grains in the world, along with wheat and rice. Together, these three crops provide the majority of the calories consumed by the human population. While most of the world's maize crop is field corn used for animal feed, industrial products, and processed foods, sweet corn represents a significant and growing portion of the overall maize market. Sweet corn plays an important role in food security by providing a nutritious, affordable, and versatile food that can be grown in a wide range of climates and conditions. Its ability to be preserved through canning and freezing makes it a valuable food for storage and distribution, helping to ensure a stable supply of nutritious food throughout the year. In developing countries, sweet corn has the potential to improve nutrition and food security by providing a palatable and nutrient-rich food that can be grown by smallholder farmers with limited resources. The relatively low input requirements of sweet corn, compared to some other crops, and its adaptability to a range of growing conditions make it a viable option for farmers in many parts of the world. The global trade in sweet corn and sweet corn products is a significant component of international agricultural commerce. Canned and frozen sweet corn are traded worldwide, and some countries have become major exporters of these products. The international sweet corn trade helps to balance supply and demand across regions and seasons, ensuring that consumers around the world have access to this beloved food. As we continue our exploration of sweet corn, let us consider some of the innovations and trends that are shaping the future of this crop. plant breeding remains one of the most important drivers of innovation in the sweet corn industry. Modern breeding programs use a combination of traditional cross-pollination techniques and advanced molecular tools to develop new varieties with improved traits. Some of the most sought-after traits in modern sweet corn breeding include enhanced sweetness, longer shelf life, improved disease resistance, better tolerance to environmental stresses, and improved nutritional profiles. One exciting area of research is the development of sweet corn varieties with enhanced levels of specific nutrients. For example, breeders are working to develop varieties with higher levels of provitamin A carotenoids, which could help to address vitamin A deficiency in populations that rely heavily on corn as a staple food. Other researchers are working to increase the levels of essential amino acids in corn protein, improving its nutritional quality and reducing the need for complementary protein sources. Advances in agricultural technology are also transforming the way sweet corn is grown. Precision agriculture tools such as GPS-guided planting and variable rate fertilizer application allow farmers to optimize their inputs and maximize their yields while minimizing waste and environmental impact. Drones and satellite imagery are used to monitor crop health and identify problems early, enabling more targeted and efficient management. The development of biological pest control methods is another important trend. Rather than relying solely on chemical pesticides, many farmers are adopting biological control strategies that use natural enemies of pests, such as parasitic wasps, predatory insects, and microbial agents, to keep pest populations in check. These biological control methods are often more sustainable and environmentally friendly than chemical approaches. Consumer preferences are also driving innovation in the sweet corn industry. There is growing demand for organic sweet corn, non-GMO sweet corn, and sweet corn grown using sustainable farming practices. Some consumers are seeking out heirloom varieties with unique flavors and histories. Others are interested in novel sweet corn products, such as sweet corn-based snacks, beverages, and convenience foods. The farm-to-table movement has also influenced the sweet corn industry, with increasing numbers of consumers seeking out locally grown sweet corn from farmers' markets and farm stands. This trend has been a boon for small-scale sweet corn growers, who can command premium prices for fresh, locally grown corn and build direct relationships with their customers. Let us also touch on the role of sweet corn in animal nutrition and other non-food uses. While sweet corn is primarily grown for human consumption, the byproducts of sweet corn processing, including husks, cobs, and trimmings, are often used as animal feed. These byproducts are a nutritious and palatable feedstuff for livestock, and their use helps to reduce waste and add value to the sweet corn processing chain. Sweet corn stalks and leaves left in the field after harvest can be used as forage for cattle or can be incorporated into the soil to improve soil organic matter and fertility. The decomposition of corn residues returns nutrients to the soil and supports the activity of beneficial soil organisms. In addition to its food and feed uses, sweet corn and its byproducts have found a variety of industrial applications. Cornstarch derived from the endosperm of the corn kernel is used in the production of paper, textiles, adhesives, and biodegradable plastics. Corn oil extracted from the germ of the kernel is used in cooking as a component of margarine and in various industrial applications. Ethanol produced by fermenting cornstarch is used as a biofuel and as an ingredient in beverages and industrial products. The versatility of corn as a raw material is truly remarkable. From food to fuel, from animal feed to industrial products, corn touches nearly every aspect of modern life. And sweet corn, while it represents just a fraction of the overall corn crop, holds a special place in this vast and varied landscape. As we approach the end of this first part of our documentary, let us reflect on the extraordinary journey of sweet corn, from its origins as a chance mutation in an ancient grain to its current status as one of the most beloved and widely consumed foods on Earth. Sweet corn is a food that connects us to the past. When we eat an ear of sweet corn, we are participating in a tradition that stretches back thousands of years, to the first farmers who recognized the sweetness in their corn and saved those special seeds for the next planting. We are connected to the indigenous peoples who cultivated and cherished this crop, to the early settlers who adopted it with enthusiasm, and to the countless breeders and farmers who have worked to improve it over the centuries. Sweet corn is also a food that connects us to each other. It is a food of gathering, of sharing, of celebration. It brings families and communities together around the table, at the cookout, at the festival. It is a food that transcends boundaries and unites people in the simple pleasure of a delicious meal. And sweet corn is a food that connects us to the natural world. It reminds us of the rhythms of the seasons, the planting in spring, the growing in summer, the harvest in fall. It reminds us of the miracle of a seed transforming into a towering plant bearing ears of golden grain. It reminds us that our food comes from the earth, nurtured by sun and rain and the labor of human hands. Sweet corn is a remarkable food. It is simple and complex, ancient and modern, humble and extraordinary. It is a food with a story worth telling and a story worth knowing. The genetic makeup of sweet corn is a fascinating subject that reveals the intricate mechanisms of nature. The sugary gene, the very first gene associated with sweet corn, was identified and characterized by scientists in the early 20th century. This gene, located on chromosome 4 of the corn genome, causes a reduction in the activity of a starch-branching enzyme, leading to an accumulation of sugars and water-soluble polysaccharides in the kernel. The result is a kernel that is sweeter, more tender, and more translucent than a field corn kernel. The shrunken 2 gene, which produces the Supersweet phenotype, is located on chromosome 3. This gene affects a different enzyme in the starch biosynthesis pathway. Specifically, it reduces the activity of add-glucose pyrophosphorylase, a key enzyme in the production of starch. The result is an even greater accumulation of sugars in the kernel, producing the intense sweetness that characterizes supersweet varieties. The sugary enhancer gene modifies the effect of the sugary gene, producing a kernel with a higher sugar content and a creamier, more tender texture than standard sugary varieties. This gene was discovered in the 1970s and quickly became an important tool in sweet corn breeding, allowing breeders to create varieties with an appealing balance of sweetness and traditional corn flavor. The interaction of these genes with each other and with other genes in the corn genome is a complex and still incompletely understood subject. Breeders must carefully manage these genetic interactions to produce varieties that combine the desired levels of sweetness, texture, flavor, and agronomic performance. This requires extensive testing and evaluation, with new experimental varieties being grown and assessed over multiple years and locations before they are released to the market. The corn genome itself is a marvel of biological complexity. The corn genome contains approximately 32,000 genes spread across 10 chromosomes. It is one of the most studied plant genomes, and the complete sequence of the corn genome was published in 2009, providing researchers with an invaluable resource for understanding the genetics of this important crop. Interestingly, the corn genome is much larger than the human genome, containing approximately 2.3 billion base pairs compared to the human genome's 3.2 billion base pairs. Much of the additional size of the corn genome is due to the presence of large amounts of repetitive DNA, including transposable elements, segments of DNA that can move from one location in the genome to another. The discovery of transposable elements in corn by the pioneering geneticist Barbara McClintock in the 1940s and 50s was one of the most important breakthroughs in the history of genetics and earned McClintock the Nobel Prize in Physiology or Medicine in 1983. McClintock's work on transposable elements, which she initially called jumping genes, was revolutionary. She discovered these elements by studying the patterns of pigmentation in corn kernels, noting that certain kernels displayed mosaics of color that could not be explained by the simple Mendelian genetics of the time. Her careful analysis revealed that genetic elements were moving within the genome, causing changes in gene expression and producing the observed patterns of pigmentation. This discovery fundamentally changed our understanding of the genome and opened up entirely new fields of research in genetics and molecular biology. The study of corn genetics has yielded many other important insights. Corn was one of the first organisms in which the phenomenon of hybrid vigor, or heterosis, was systematically studied and exploited. Hybrid vigor refers to the tendency of hybrid offspring, the result of crossing two genetically different parent lines, to be more vigorous, more productive, and more resilient than either parent. The exploitation of hybrid vigor in corn breeding, beginning in the early 20th century, led to dramatic increases in corn yields and was one of the key factors in the agricultural revolution that transformed food production in the 20th century. The development of hybrid sweet corn varieties follows the same basic principles as hybrid field corn breeding. Breeders develop inbred lines plants that have been self-pollinated for many generations until they are genetically uniform, and then cross these inbred lines to produce hybrid seed. The resulting hybrid plants exhibit hybrid vigor, producing higher yields, more uniform ears, and better overall performance than open pollinated varieties. The production of hybrid sweet corn seed is a specialized and labor-intensive process. In a hybrid seed production field, rows of the two inbred parent lines are planted in a specific pattern. The tassels of one parent line, the female parent, are removed before they shed pollen, a process called detasseling. This ensures that the female parent plants can only be pollinated by pollen from the other parent line, the male parent. The resulting seed harvested from the female parent plants is the hybrid seed that will be sold to farmers and gardeners. Detasseling is one of the iconic tasks of corn country summers. Traditionally, it has been done by hand, with crews of workers walking through the fields and pulling the tassels from the female parent plants. In recent years, mechanical detasseling machines have been developed to assist with this task, but hand detasseling remains an important part of the process, particularly for removing any tassels that the machines miss. Now, as we prepare to close this first part of our documentary, let us consider a few more fascinating aspects of sweet corn that will set the stage for the continuation of our journey in Part 2. Sweet corn has inspired a remarkable amount of scientific research, not only in genetics and plant breeding, but also in food science, nutrition, and agricultural engineering. Researchers have studied every aspect of sweet corn, from the biochemistry of its sweetness to the optimal methods for cooking, preserving, and packaging it. Food scientists have devoted considerable attention to understanding the factors that influence the flavor of sweet corn. Sweetness, of course, is the most obvious flavor attribute, but the flavor of sweet corn is actually a complex interplay of many compounds. In addition to sugars, sweet corn kernels contain volatile aromatic compounds that contribute to the characteristic corny aroma and flavor. One of the most important of these compounds is dimethyl sulfide, a volatile sulfur compound that is produced during the cooking of sweet corn and is responsible for much of the cooked corn aroma. Other volatile compounds that contribute to the flavor of sweet corn include various aldehydes, alcohols, and esters. The specific blend of these compounds varies among varieties and is influenced by factors such as maturity, growing conditions, and post-harvest handling. This is why different varieties of sweet corn can taste distinctly different, even when grown and prepared in the same way. The texture of sweet corn is another important quality attribute that has been extensively studied. The tenderness of the kernel, the crispness of the bite, the creaminess of the interior, all of these textural characteristics contribute to the overall eating experience. The genetic makeup of the corn, whether it carries the SU, C, or SH2 gene, has a major influence on texture, as does the stage of maturity at harvest and the method of cooking. Food scientists have also studied the color of sweet corn kernels, both as a quality attribute and as an indicator of nutritional value. The intensity of the yellow color in sweet corn kernels is directly related to the concentration of carotenoid pigments, including beta-carotene, lutein, and zeaxanthin. Deeper yellow kernels generally contain higher levels of these beneficial compounds. White sweet corn kernels, while still nutritious, contain significantly lower levels of carotenoids. The study of sweet corn quality has led to the development of standardized grading systems that are used to evaluate and classify sweet corn for commercial sale. These grading systems assess factors such as ear size, kernel development, freedom from defects, and overall appearance. Sweet corn that meets the highest quality standards is designated as the top grade and commands the highest prices in the market. The development of new sweet corn varieties is a continuous process, driven by the desire to create products that better meet the needs and preferences of consumers. Modern sweet corn breeding programs use a combination of field trials, laboratory analyses, and sensory evaluations to assess new varieties. Sensory panels, groups of trained tasters who evaluate the flavor, texture, and appearance of sweet corn samples, play a crucial role in the variety development process, ensuring that new varieties not only perform well in the field but also taste great on the plate. One of the most exciting recent developments in sweet corn breeding is the creation of varieties with novel kernel colors. While yellow, white, and bicolor have long been the standard colors for sweet corn, breeders have recently developed varieties with red, purple, blue, and even multicolored kernels. These colored sweet corn varieties contain anthocyanins, a class of powerful antioxidants that give them their striking hues. Anthocyanins have been associated with a range of health benefits, including reduced inflammation, improved cardiovascular health, and enhanced cognitive function. The market for these novel colored sweet corn varieties is still small, but it is growing as consumers become more interested in unique and nutritious foods. Farmers markets and specialty food stores have been early adopters of colored sweet corn, and some forward-thinking chefs have incorporated it into their menus, where its striking appearance and potential health benefits make it a conversation piece as well as a delicious food. As we bring this first part of our documentary to a close, let us take a moment to appreciate the sheer wonder of sweet corn. It is a food that has been shaped by thousands of years of human ingenuity and natural evolution. It is a food that nourishes the body and delights the senses. It is a food that brings people together and connects us to the land. Let us begin this second chapter with a closer look at the sensory experience of eating sweet corn, the taste, the aroma, the texture, the sound, and even the visual appeal, because understanding why we love sweet corn so much requires understanding how our senses interact with this remarkable food. When you peel back the husk of a freshly picked ear of sweet corn, the first thing that hits you is the aroma. It is a green, grassy, slightly sweet scent, the smell of summer distilled into a single moment. That aroma comes from a complex mixture of volatile organic compounds released from the husk, the silk, and the kernels themselves. Scientists have identified more than 200 individual volatile compounds in sweet corn, each contributing its own subtle note to the overall fragrance. As you bring the ear closer and examine the kernels, the visual appeal becomes apparent. The rows of plump, glistening kernels, arranged in precise geometric patterns, have a beauty that is both natural and almost mathematical. The color, whether golden yellow, creamy white, or a patchwork of both, signals freshness and ripeness. Our brains are wired to associate bright, saturated colors in food with nutrition and quality, and sweet corn delivers on that promise with every ear. When you take that first bite, the experience intensifies. The kernels resist for just a fraction of a second before bursting open, releasing a rush of sweet, milky juice. The texture is simultaneously crisp and creamy, a paradox that is one of sweet corn's most endearing qualities. The flavor is a blend of sweetness, a subtle grassiness, a hint of butter even before any butter has been added, and a depth of savory complexity that the Japanese might call umami. It is a flavor that is at once familiar and endlessly satisfying. Even the sound of eating sweet corn is part of the experience. The pop and crunch of the kernels as your teeth break through them, the slight squeak of the kernels against the cob, these auditory cues contribute to the perception of freshness and quality. Food scientists have demonstrated that the sounds we hear while eating significantly influence our perception of taste and texture, and the distinctive sounds of eating corn on the cob are an integral part of the overall experience. This multisensory experience is one of the reasons why sweet corn on the cob remains one of the most popular ways to eat sweet corn, despite the availability of more convenient forms such as canned and frozen kernels. There is something irreplaceable about the act of eating corn off the cob, the physical engagement, the sensory richness, the primal satisfaction. It is an eating experience that cannot be replicated by any other food. Now let us delve into the world of sweet corn varieties in greater detail, because the diversity of sweet corn is one of its most remarkable and underappreciated qualities. We touched on some popular varieties in Part 1, but the full catalog of sweet corn varieties is staggering in its breadth. There are quite literally hundreds of named sweet corn varieties available to growers and gardeners around the world, each with its own unique combination of traits. Let us start with some of the classic heirloom varieties that have stood the test of time. Black Mexican, also known as Black Aztec, is one of the most visually striking sweet corn varieties in existence. When harvested at the sweet corn stage, its kernels are a deep bluish-purple color that darkens to nearly black as the corn matures. Despite its unusual appearance, Black Mexican has a delicious, rich flavor that many corn enthusiasts consider superior to that of standard yellow varieties. The dark coloring of the kernels is due to high concentrations of anthocyanin pigments, which are potent antioxidants with numerous potential health benefits. Stowell's Evergreen, introduced in 1848, is one of the oldest named sweet corn varieties still in cultivation. This white variety was legendary for its ability to remain in the sweet, edible stage for an extended period, hence the name Evergreen. While modern varieties have surpassed it in sweetness and shelf life, Stowell's Evergreen retains a loyal following among heirloom enthusiasts who appreciate its rich, old-fashioned corn flavor and its historical significance. Golden Bantam, as we mentioned in Part 1, was a landmark variety in the history of sweet corn. Introduced in 1902 by a seed company, Golden Bantam was one of the first yellow sweet corn varieties to gain mainstream acceptance. Before Golden Bantam, many people considered yellow corn to be inferior to white corn and suitable only for animal feed. Golden Bantam changed this perception forever, demonstrating that yellow sweet corn could be just as sweet and flavorful as its white counterparts. Today, yellow sweet corn dominates the market, and Golden Bantam is widely regarded as the variety that started it all. Howling Mob is a delightfully named heirloom variety that dates back to the early 1900s. According to legend, the variety got its name because crowds of eager buyers would form a howling mob at the market whenever this exceptionally sweet and tender corn was offered for sale. Whether or not the story is true, Howling Mob remains a beloved variety among heirloom gardeners, prized for its early maturity and outstanding flavor. Moving into the modern era, the variety landscape becomes even more diverse. Breeders have created an astonishing array of hybrid varieties, each tailored to specific growing conditions, market requirements, and consumer preferences. Incredible is a popular sugar-enhanced variety that lives up to its name. It produces large, well-filled ears with bright yellow kernels that are exceptionally sweet and tender. Incredible is widely adapted and performs well in a range of growing conditions, making it a favorite of both commercial growers and home gardeners. Ambrosia is a bicolor sugar-enhanced variety that has become one of the most popular sweet corn varieties for home gardens. Its ears feature a beautiful mix of yellow and white kernels, and its flavor is sweet, creamy, and complex. Ambrosia matures relatively early, making it a good choice for gardeners in regions with shorter growing seasons. Mirai is a series of sweet corn varieties developed by a Japanese-born plant breeder who dedicated his career to creating the sweetest corn possible. Mirai varieties are known for their extraordinary sweetness. Some have been measured at sugar levels approaching those of certain fruits. The Mirai series has developed a cult following among corn aficionados who seek out these varieties for their unparalleled flavor. Serendipity is a Triplesweet variety, a relatively new genetic category that combines the SU, C, and SH2 genes in a single variety. The result is a corn with the best qualities of all three genetic types: the traditional corn flavor of SU varieties, the tenderness of C varieties, and the intense sweetness and extended shelf life of SH2 varieties. Triplesweet varieties like Serendipity represent the cutting edge of sweet corn breeding and are gaining popularity among growers who want the ultimate in sweet corn quality. Honey and Cream is another beloved bicolor variety, known for its balanced sweetness and its attractive mix of golden and ivory kernels. It is a reliable performer in the garden and produces ears of consistently high quality. Nirvana is a supersweet variety that has gained a reputation for its exceptional flavor and its vigorous, productive plants. The name itself suggests the transcendent eating experience that this variety provides, and for many corn lovers, it delivers on that promise. Let us now explore some of the more unusual and exotic forms of sweet corn that exist around the world. In parts of Southeast Asia, a type of sweet corn known as waxy corn or glutinous corn is widely grown and consumed. Waxy corn has a distinctive chewy, sticky texture that is quite different from the crisp, juicy texture of standard sweet corn. It is often steamed or boiled and eaten as a snack, and it is particularly popular in countries such as Thailand, Laos, and Vietnam. The waxy texture is caused by a different starch composition. Waxy corn contains almost entirely amylopectin, a branch starch molecule, whereas standard corn contains a mix of amylopectin and amylose. Baby corn, those tiny, immature ears of corn that are commonly found in stir-fries and Asian dishes, is harvested from standard corn plants before the kernels have developed. While baby corn can be produced from any corn variety, it is most commonly grown from field corn or specialized baby corn varieties. Baby corn is valued for its tender, delicate texture and its mild, slightly sweet flavor. It is harvested when the ears are only 2 to 4 inches long, just as the silks are beginning to emerge. Ornamental corn, also known as Indian corn or flint corn, is not a type of sweet corn but deserves mention because of its close relationship to sweet corn and its cultural significance. Ornamental corn comes in a dazzling array of colors: red, blue, purple, orange, white, and multicolored, and is used primarily for decoration, particularly during autumn festivals and harvest celebrations. The kernels of ornamental corn are hard and starchy, unsuitable for fresh eating, but they can be ground into flour or popped as popcorn. Speaking of popcorn, this is another close relative of sweet corn that has its own fascinating history. Popcorn is a specific type of corn with a hard, moisture-sealed hull that allows pressure to build inside the kernel when it is heated. When the internal pressure becomes great enough, the kernel explodes, turning inside out and producing the fluffy white puff that we all know and love. Archaeological evidence suggests that popcorn has been eaten for thousands of years. Popped kernels estimated to be over 5,000 years old have been found in archaeological sites. Now, let us examine the role of sweet corn in the cuisines of various regions and cultures around the world. In many parts of Latin regions, sweet corn is a fundamental ingredient in both everyday cooking and festive dishes. We discussed Elote and Esquites in Part 1, but the culinary applications of sweet corn in Latin cuisine go far beyond these popular street foods. Humitas are a traditional dish found in several South regions, consisting of a paste made from fresh sweet corn kernels, often mixed with onions, spices, and sometimes cheese, wrapped in corn husks and steamed or boiled. Humitas are deeply rooted in indigenous culinary traditions and represent one of the oldest known preparations of fresh sweet corn. In many Caribbean nations, sweet corn is used in soups, stews, and fritters. Corn soup, a rich, creamy blend of corn kernels, coconut milk, and aromatic spices, is a beloved comfort food in several Caribbean cuisines. The combination of sweet corn and coconut milk creates a flavor that is simultaneously tropical and homey. In parts of Europe, sweet corn has a more recent culinary history. Sweet corn was not widely consumed in Europe until the 20th century, and even today it is less central to European cuisines than it is in the Western Hemisphere. However, sweet corn has steadily gained popularity across Europe, particularly in the United Kingdom, France, and Spain. Canned sweet corn is widely available in European supermarkets, and fresh sweet corn has become increasingly common at farmers' markets and produce stands during the summer months. In the United Kingdom, sweet corn is often served as a simple side dish, boiled or microwaved and served with butter. It is also a popular ingredient in salads, sandwiches, and jacket potatoes. Sweet corn and tuna salad, a combination of canned sweet corn and canned tuna dressed with mayonnaise, is a classic British lunch dish that can be found in cafes and sandwich shops across the country. In France, sweet corn is less traditional but has found a niche in modern French cooking. Some innovative French chefs have incorporated sweet corn into soups, sauces, and even desserts, treating it with the same respect and creativity that they bring to any other fine ingredient. Sweet corn velouté, a silky, elegant soup made from pureed sweet corn, cream, and delicate seasonings, is a dish that demonstrates the potential of sweet corn in haute cuisine. In parts of Africa, corn in various forms is a dietary mainstay, and sweet corn is enjoyed alongside its field corn cousins. Grilled sweet corn is a ubiquitous street food in many African cities, often seasoned with salt, pepper, and sometimes a squeeze of citrus or a sprinkle of ground spices. The smoky, charred flavor of street grilled corn is one of the characteristic flavors of urban African food culture. In East and Southeast Asia, sweet corn has been adopted with remarkable enthusiasm and creativity. In Japan, sweet corn is one of the most popular pizza toppings, a fact that never fails to surprise visitors from other parts of the world. But the Japanese love affair with sweet corn goes far beyond pizza. Sweet corn is used in soups, salads, rice dishes, and ramen. It is a popular filling for bread and pastries. It is even found in ice cream and other frozen desserts. The Japanese appreciation for sweet corn reflects the broader Japanese culinary philosophy of celebrating the natural sweetness and flavor of fresh, seasonal ingredients. In Korea, sweet corn is enjoyed as a snack, often boiled or steamed and sold by street vendors. Corn cheese, a popular bar snack consisting of sweet corn kernels mixed with mayonnaise and melted cheese, baked until bubbly and golden, is a beloved dish that perfectly illustrates the Korean talent for creating irresistibly addictive flavor combinations. In China, sweet corn has become increasingly popular in recent decades, as rising incomes and changing dietary preferences have driven demand for diverse and flavorful foods. Sweet corn is used in soups, stir-fries, and conges, and it is also eaten as a simple snack, boiled or steamed and served on the cob. Chinese sweet corn varieties tend to be less sweet than their Western counterparts, reflecting local taste preferences. In India, sweet corn has experienced a surge in popularity in recent years, particularly in urban areas. Grilled sweet corn on the cob, rubbed with a mixture of lime juice, salt, and chili powder, is a beloved street food. Sweet corn is also used in chaat, a category of savory snacks that combine multiple flavors and textures, and in various curries and rice dishes. In the Philippines, sweet corn is a popular ingredient in desserts and beverages. Maize con hilo, a refreshing treat made from sweet corn kernels, shaved ice, milk, and sugar, is a classic Filipino dessert that is enjoyed year-round but is especially popular during the hot summer months. Sweet corn is also used in bibingka, a traditional rice cake, and in various other Filipino sweets and snacks. In Thailand, sweet corn is used in both savory and sweet dishes. Kao pad ping, grilled sweet corn on the cob, is a popular street snack, often brushed with a mixture of coconut cream and salt before grilling. Sweet corn is also used in curries, salads, and desserts, where its natural sweetness complements the bold, complex flavors of Thai cuisine. The global spread of sweet corn across such diverse culinary traditions is a testament to its universal appeal. Regardless of the cuisine, regardless of the culture, sweet corn's natural sweetness, versatility, and satisfying texture make it a welcome addition to the table. Now, let us explore in greater depth the health benefits and potential medicinal properties of sweet corn. We discussed the basic nutritional profile of sweet corn in Part 1, but there is much more to say about the health effects of this food. Scientists around the world have been studying the bioactive compounds in sweet corn and their potential effects on human health, and the findings are both encouraging and fascinating. One area of active research is the potential role of sweet corn in cancer prevention. Several compounds found in sweet corn, including ferulic acid, anthocyanins in colored varieties, and other phenolic compounds, have demonstrated anti-cancer properties in laboratory studies. These compounds appear to work through multiple mechanisms, including the neutralization of free radicals, the inhibition of cancer cell growth, and the promotion of apoptosis, the programmed death of damaged or abnormal cells. A particularly interesting study found that the antioxidant activity of sweet corn actually increases when it is cooked. This is somewhat unusual, as many foods lose antioxidant activity during cooking. The researchers found that the heat of cooking releases bound phenolic compounds from the cell matrix of the corn kernels, making them more available for absorption by the body. This finding suggests that cooked sweet corn may actually be more beneficial from an antioxidant perspective than raw sweet corn. The eye health benefits of sweet corn deserve further exploration. Lutein and zeaxanthin, the two carotenoids found in yellow sweet corn, are the only carotenoids that accumulate in the macula, the central part of the retina responsible for sharp, detailed vision. These pigments act as a natural filter for blue light, which can damage the photoreceptor cells of the retina over time. By filtering blue light and neutralizing free radicals, lutein and zeaxanthin help to protect the macula from damage and reduce the risk of age-related macular degeneration. Age-related macular degeneration is the leading cause of irreversible vision loss in people over the age of 50. It affects millions of people worldwide, and its prevalence is expected to increase as the global population ages. The potential of dietary interventions, including increased consumption of lutein and zeaxanthin-rich foods like sweet corn, to reduce the risk of this devastating condition, is a subject of intense research interest. Some studies have also suggested that lutein and zeaxanthin may play a role in protecting the skin from sun damage. These carotenoids accumulate in the skin, where they may help to filter ultraviolet light and reduce the oxidative damage caused by sun exposure. While this research is still in its early stages, it suggests yet another potential benefit of consuming sweet corn and other carotenoid-rich foods. The cardiovascular benefits of sweet corn are another area of scientific interest. The fiber, potassium, folate, and phytosterols in sweet corn may all contribute to improved cardiovascular health. Fiber helps to lower cholesterol levels by binding to cholesterol in the digestive tract and promoting its excretion. Potassium helps to regulate blood pressure by counteracting the effects of sodium. Folate helps to lower levels of homocysteine, an amino acid that at elevated levels is associated with an increased risk of heart disease. And phytosterols, as we discussed in Part 1, help to lower blood cholesterol levels by competing with cholesterol for absorption. Sweet corn also contains small amounts of omega-6 fatty acids, primarily in the form of linoleic acid. While the relationship between omega-6 fatty acids and health is complex and sometimes controversial, linoleic acid is an essential fatty acid that the body cannot produce on its own and must obtain from food. It plays important roles in cell membrane structure, skin barrier function, and inflammatory signaling. The role of sweet corn in gut health is an area of growing scientific interest. The fiber and resistant starch in sweet corn serve as prebiotics, substances that feed and support the growth of beneficial bacteria in the gut. A healthy and diverse gut microbiome has been associated with numerous health benefits, including improved immune function, better metabolic health, reduced inflammation, and even improved mental health through the gut-brain axis. Recent research has revealed that the gut microbiome, the vast community of microorganisms that inhabits the human digestive tract, plays a far more important role in health and disease than was previously appreciated. The composition and diversity of the gut microbiome are influenced by diet and foods that promote a healthy microbiome, such as fiber-rich vegetables including sweet corn, are increasingly recognized as important components of a health-promoting diet. The potential benefits of sweet corn for blood sugar management are nuanced and worth discussing in detail. While sweet corn does contain carbohydrates and has a moderate glycemic index, it also contains fiber and resistant starch that slow the absorption of glucose into the bloodstream. This means that the blood sugar response to sweet corn is more gradual and sustained than the response to refined carbohydrate foods. For individuals with diabetes or prediabetes, incorporating sweet corn into a balanced meal that includes protein and healthy fats can help to mitigate its glycemic impact. Some research has suggested that the resistant starch in sweet corn may actually improve insulin sensitivity over time, making the body more efficient at managing blood sugar levels. This finding is consistent with a growing body of evidence that resistant starch, by promoting the production of short-chain fatty acids in the gut, can have beneficial effects on metabolic health. Let us now turn our attention to the environmental and sustainability challenges facing sweet corn production in the 21st century. Climate change is one of the most significant challenges facing agriculture today, and sweet corn is not immune to its effects. Rising temperatures, changing rainfall patterns, increased frequency of extreme weather events, and shifting pest and disease pressures are all affecting sweet corn production in various parts of the world. Higher temperatures can affect sweet corn in several ways. While sweet corn is a warm season crop that requires heat to grow, excessive heat can be detrimental. Temperatures above 95 degrees Fahrenheit can interfere with pollination, as pollen becomes less viable at extreme temperatures. Prolonged heat waves can also accelerate the conversion of sugars to starch in the kernels, reducing the window of time during which the corn is at peak sweetness. Drought is another climate-related challenge. As we discussed in Part 1, sweet corn requires a consistent supply of moisture, particularly during the critical tasseling and silking stage. Droughts that occur during this period can cause severe yield losses. Climate projections suggest that many major sweet corn growing regions will experience increased drought frequency and severity in the coming decades, placing additional stress on water resources and irrigation systems. Conversely, excessive rainfall and flooding can also damage sweet corn crops. Waterlogged soils deprive corn roots of oxygen, leading to root damage and reduced plant growth. Heavy rains during the harvest period can delay harvesting, allowing the corn to pass beyond its peak stage of sweetness. And flooding can introduce soil-borne pathogens that cause root rot and other diseases. The shifting ranges of pests and diseases are another concern. As temperatures warm, insects and pathogens that were previously limited to warmer regions are expanding their ranges into areas where sweet corn has historically been grown with minimal pest pressure. This can increase the need for pest management interventions and require the development of new resistant varieties. In response to these challenges, researchers and farmers are working to develop and implement climate-adaptive strategies for sweet corn production. These strategies include the breeding of heat-tolerant and drought-tolerant varieties, the adoption of water-efficient irrigation technologies, the use of cover crops and mulches to improve soil moisture retention, and the implementation of integrated pest management systems that can adapt to changing pest pressures. The carbon footprint of sweet corn production is another environmental consideration. The production, transportation, and processing of sweet corn all require energy and generate greenhouse gas emissions. The manufacture of nitrogen fertilizer, in particular, is a significant source of emissions, as the Haber-Bosch process used to produce synthetic nitrogen fertilizer requires large amounts of natural gas. Efforts to reduce the carbon footprint of sweet corn production include the development of more efficient fertilizer formulations and application methods, the adoption of renewable energy sources for processing and transportation, and the implementation of soil management practices that increase carbon sequestration in agricultural soils. Cover cropping, reduced tillage, and the application of organic amendments can all help to increase the amount of carbon stored in the soil, offsetting some of the emissions associated with crop production. The issue of soil health is critically important for the long-term sustainability of sweet corn production. Healthy soils are the foundation of productive agriculture, and the degradation of soil health through erosion, compaction, nutrient depletion, and loss of organic matter is a serious threat to the future of food production. Sweet corn, like all crops, depends on healthy soils to provide the nutrients, water, and physical support that the plants need to grow and produce. Farmers who prioritize soil health through practices such as crop rotation, cover cropping, composting, and reduced tillage are investing in the long-term productivity of their land. Crop rotation, the practice of growing different crops in succession on the same piece of land, is particularly important for sweet corn. Growing sweet corn in the same field year after year can lead to a buildup of soil-borne pests and diseases and can deplete specific nutrients from the soil. Rotating sweet corn with other crops, such as legumes, small grains, or cover crops, helps to break pest and disease cycles, restore soil fertility, and improve soil structure. The use of cover crops, plants grown primarily to benefit the soil rather than for harvest, is gaining popularity among sweet corn growers. Cover crops can reduce erosion, suppress weeds, improve soil structure, increase organic matter, and fix atmospheric nitrogen in the soil in the case of legume cover crops. When cover crops are terminated and their residues are incorporated into the soil, they provide a source of nutrients and organic matter that benefits the subsequent sweet corn crop. Biodiversity conservation is another important aspect of sustainable sweet corn production. While commercial sweet corn fields are, by nature, monocultures, the broader agricultural landscape can be managed to support biodiversity. Planting hedgerows, maintaining buffer strips along waterways, creating habitat for pollinators and beneficial insects, and preserving natural areas within and around farmland can all help to support the diverse web of life that underpins a healthy agricultural ecosystem. Let us now consider the social and economic dimensions of sweet corn production, with a focus on the people who grow and harvest this crop. Sweet corn farming is a labor-intensive endeavor, particularly when the crop is grown for the fresh market. Planting, cultivating, irrigating, scouting for pests and diseases, and harvesting all require significant amounts of human labor. In many regions, the sweet corn harvest is one of the most labor-intensive periods of the entire agricultural year, requiring crews of workers to hand-pick thousands of ears per day. The labor force that harvests sweet corn is often composed of migrant and seasonal workers who travel from region to region following the harvest seasons of various crops. These workers perform physically demanding work under challenging conditions, often in extreme heat, with long hours and with limited access to shade, water, and restroom facilities. The working conditions and compensation of agricultural laborers are important social justice issues that deserve attention and action. Efforts to improve the working conditions of sweet corn harvest workers include the implementation of labor standards and regulations, the provision of shade structures and cooling stations in the fields, the availability of clean drinking water and sanitation facilities, and fair compensation practices. Some farms and processors have adopted voluntary certification programs that guarantee minimum labor standards and working conditions. The economic challenges facing sweet corn farmers are significant and multifaceted. Input costs, including seed, fertilizer, pesticides, fuel, and labor, have risen steadily over the years, while sweet corn prices have not always kept pace. Weather-related crop losses, market fluctuations, and competition from imported sweet corn products can all affect the profitability of sweet corn farming. Small-scale sweet corn farmers, in particular, face unique challenges. They may lack the economies of scale that larger operations enjoy, and they may have limited access to credit, technology, and markets. For these farmers, direct marketing, selling sweet corn directly to consumers through farm stands, farmers markets, and community-supported agriculture programs, can be a vital strategy for capturing a greater share of the food dollar and building a loyal customer base. The consolidation of the sweet corn processing industry has also affected the economic landscape for sweet corn farmers. A relatively small number of large companies dominate the canned and frozen sweet corn market, giving them significant bargaining power in their relationships with growers. Contract farming arrangements in which processors specify the varieties, planting dates, and management practices and agree to purchase the harvested crop at a predetermined price provide farmers with a guaranteed market but may limit their flexibility and independence. Despite these challenges, sweet corn farming remains a rewarding occupation for many growers. The satisfaction of producing a high-quality food that is loved by millions of people, the connection to the land and the rhythms of the seasons, and the pride of carrying on agricultural traditions that may span generations, these intangible rewards are a powerful motivation for sweet corn farmers around the world. Let us now examine some of the more unusual and surprising uses of sweet corn and its byproducts. Sweet corn has found its way into the world of cosmetics and personal care products. Corn starch, derived from the endosperm of corn kernels, is a common ingredient in body powders, dry shampoos, and cosmetic formulations, where it serves as an absorbent and a texturizing agent. Corn oil, extracted from the germ of the kernel, is used in some moisturizers and skin care products due to its emollient properties. Corn silk, the thread-like strands that emerge from the top of the ear, has been used in traditional medicine systems around the world for centuries. In traditional Chinese medicine, corn silk is used to treat edema, urinary disorders, and high blood pressure. In parts of Central and South regions, corn silk tea is a popular folk remedy for kidney and bladder ailments. Modern scientific research has confirmed that corn silk contains bioactive compounds, including flavonoids, saponins, and tannins, that have diuretic, anti-inflammatory, antioxidant, and blood sugar-lowering properties. The pharmaceutical potential of corn silk is an active area of research. Scientists are investigating the use of corn silk extracts as natural alternatives to synthetic diuretics and anti-inflammatory drugs. Some studies have shown that corn silk extract can reduce blood pressure in animal models, suggesting a potential application in the management of hypertension. Other studies have demonstrated antioxidant and anti-diabetic effects, though more research is needed to confirm these findings in humans. Sweet corn husks have been used for centuries as a natural wrapping material for foods. In addition to their use in tamales, corn husks have been used to wrap and cook fish, meat, and vegetables in various culinary traditions. The husks impart a subtle, earthy flavor to the food and help to retain moisture during cooking. In recent years, there has been growing interest in using corn husks as a biodegradable alternative to plastic wrapping materials, aligning with broader efforts to reduce plastic waste and promote sustainability. Corn cobs, the hard central core of the ear, have a surprisingly wide range of uses. Ground corn cob material is used as an abrasive in industrial cleaning and polishing applications. It is used as a carrier for pesticides and herbicides in agricultural applications. It is used as a component of animal bedding, where its absorbency and natural scent-reducing properties are valued. And it is used as a biomass fuel, providing a renewable source of energy when burned. In some regions, corn cobs have traditionally been used to make smoking pipes. Corn cob pipes have a long and colorful history, and they were once one of the most common types of pipes in many parts of the world. While they have largely been replaced by pipes made from other materials, corn cob pipes remain popular among collectors and enthusiasts, and they continue to be manufactured by a small number of dedicated producers. One of the most innovative modern uses of sweet corn byproducts is in the production of biodegradable plastics and packaging materials. Polylactic acid, or PLA, is a biodegradable plastic that can be produced from corn starch. PLA can be used to make a wide range of products, including food containers, packaging materials, disposable cutlery, and even clothing fibers. Because PLA is derived from a renewable resource and is compostable under the right conditions, it is seen as a more environmentally friendly alternative to conventional petroleum-based plastics. Let us now consider the future of sweet corn, the trends, innovations, and challenges that will shape this crop in the decades to come. One of the most exciting trends in sweet corn production is the growing interest in locally grown, farm-fresh sweet corn. Consumers are increasingly seeking out sweet corn from local farmers, driven by a desire for the freshest possible product, a commitment to supporting local agriculture, and a growing awareness of the environmental costs of long-distance food transportation. Farmers' markets, farm stands, and community-supported agriculture programs have become important outlets for locally grown sweet corn. These direct marketing channels allow farmers to sell their corn at retail prices, capturing a larger share of the food dollar and building direct relationships with their customers. For consumers, buying sweet corn from a local farmer means getting the freshest, most flavorful corn possible, corn that was often picked that very morning. The concept of farm to table has gained tremendous momentum in recent years, and sweet corn is one of the foods that exemplifies this movement most perfectly. The difference in flavor between sweet corn that was picked an hour ago and sweet corn that has been sitting in a distribution center for several days is profound, and once you have tasted truly fresh sweet corn, it is hard to go back. Another important trend is the growing demand for organic sweet corn. Organic farming practices, which prohibit the use of synthetic pesticides, fertilizers, and genetically modified organisms, are increasingly popular among consumers who are concerned about the environmental and health impacts of conventional agriculture. Organic sweet corn production has grown significantly in recent years, and organic sweet corn is now widely available in supermarkets, natural food stores, and farmers' markets. The development of new sweet corn varieties with enhanced nutritional profiles is an area of active research. Breeders are working to develop varieties with higher levels of specific nutrients, such as provitamin carotenoids, anthocyanins, and essential amino acids. These biofortified varieties have the potential to address nutrient deficiencies in populations that rely heavily on corn as a staple food, contributing to improved public health outcomes. One particularly promising line of research involves the development of orange-kerneled sweet corn varieties with exceptionally high levels of provitamin carotenoids. Vitamin A deficiency is a major public health problem in many developing countries, causing blindness, immune dysfunction, and increased mortality, particularly among children and pregnant women. Biofortified corn varieties with enhanced provitamin, a content could help to address this deficiency in a sustainable and culturally appropriate way. Advances in gene editing technology, particularly the CRISPR-Cas9 system, are opening up new possibilities for sweet corn improvement. Unlike traditional genetic modification, which involves inserting foreign genes into an organism's genome, gene editing allows scientists to make precise, targeted changes to an organism's existing genes. This technology could be used to enhance the sweetness, nutritional value, disease resistance, or environmental adaptability of sweet corn varieties, potentially accelerating the pace of crop improvement. However, the use of gene editing in food crops is a subject of ongoing debate. While many scientists and regulators view gene-edited crops as fundamentally different from genetically modified organisms, some consumers and advocacy groups have expressed concerns about the safety and ethical implications of this technology. The regulatory framework for gene-edited crops is still evolving, and the public acceptance of gene-edited sweet corn will depend on transparent communication and a demonstrated commitment to safety. Precision agriculture technologies are transforming the way sweet corn is grown. GPS-guided planting equipment allows farmers to plant sweet corn seeds at precisely the right depth, spacing, and density, optimizing plant populations and reducing seed waste. Variable rate application technology enables farmers to apply fertilizers and other inputs at varying rates across a field, matching the input rate to the specific needs of each area. This precision reduces waste, minimizes environmental impact, and improves the efficiency of input use. Drones and satellite-based remote sensing are being used to monitor sweet corn fields in real time, providing farmers with detailed information about crop health, moisture status, pest pressure, and other factors. This information allows farmers to make more informed management decisions, respond quickly to emerging problems, and optimize their operations for maximum productivity and sustainability. Robotic harvesting is an emerging technology that could fundamentally change the way sweet corn is harvested. Researchers are developing robotic systems that can identify ripe ears of sweet corn, determine their readiness for harvest, and pick them with precision and care. While this technology is still in the early stages of development, it has the potential to address labor shortages, reduce harvesting costs, and improve the consistency of harvest quality. Vertical farming and controlled environment agriculture are other innovative approaches that could play a role in the future of sweet corn production. While sweet corn is not currently a common crop in vertical farms, its large size and substantial light requirements make it challenging to grow indoors. Advances in LED lighting technology, hydroponic and aeroponic growing systems, and climate control could eventually make indoor sweet corn production feasible. Indoor farming would allow sweet corn to be grown year-round, regardless of climate, and could dramatically reduce the need for pesticides and water. The development of sweet corn varieties specifically adapted for vertical farming environments, with shorter plant heights, smaller ear sizes, and more efficient light use, could accelerate the adoption of this approach. While this is still largely speculative, it reflects the broader trend toward innovation and diversification in food production systems. Let us now take a few moments to discuss some of the myths, misconceptions, and frequently asked questions about sweet corn. One common misconception is that sweet corn is unhealthy because it is high in sugar. While sweet corn does contain natural sugars, the amount of sugar in a serving of sweet corn is relatively modest, comparable to that of many other vegetables, and significantly less than that of most fruits. The sugars in sweet corn are naturally occurring and are accompanied by fiber, vitamins, minerals, and antioxidants that make sweet corn a nutritious food. Classifying sweet corn as unhealthy because of its sugar content is a simplification that does not hold up to scientific scrutiny. Another common misconception is that all corn is genetically modified. While it is true that a large proportion of the world's field corn crop is genetically modified, the situation is different for sweet corn. A significant proportion of the sweet corn grown for fresh consumption is not genetically modified. Consumers who wish to avoid genetically modified sweet corn can look for organic sweet corn, which is by definition non-GMO, or can seek out sweet corn labeled as non-GMO verified. Some people believe that sweet corn has no nutritional value, that it is empty calories with nothing to offer beyond carbohydrates. This is simply not true. As we have discussed extensively in this documentary, sweet corn is a good source of fiber, vitamins, minerals, and antioxidants. It is a nutritious food that can be a valuable part of a balanced diet. There is also a common question about whether sweet corn is a vegetable or a grain. The answer, as we discussed earlier, is that it is both botanically a grain, but culinarily and nutritionally classified as a vegetable when harvested at the immature sweet stage. This dual identity is a unique and interesting aspect of sweet corn's character. Another frequently asked question is whether it is safe to eat raw sweet corn. The answer is yes, raw sweet corn is perfectly safe to eat, as long as it is fresh and clean. In fact, many corn enthusiasts prefer raw sweet corn for its crisp texture and bright, uncooked flavor. Eating raw sweet corn is a wonderful way to appreciate the natural sweetness and freshness of the kernels. Some consumers wonder about the digestibility of sweet corn, particularly after noticing that corn kernels sometimes appear intact in the stool. As we mentioned in Part 1, the outer hull of the corn kernel is made of cellulose, which the human digestive system cannot break down. However, the interior of the kernel, the starchy, sugary endosperm, is fully digested and absorbed. What you see in the stool is merely the empty cellulose hull, not an undigested kernel. This is a normal and harmless phenomenon. Let us now explore the aesthetic and artistic dimensions of sweet corn. Sweet corn has been a muse for artists, photographers, and designers for centuries. The striking visual appearance of sweet corn, the vibrant colors, the geometric patterns, the contrast between the green husk and the golden kernels has inspired countless works of art and design. In the world of photography, sweet corn is a popular subject for still life compositions. The interplay of light and shadow on the rows of kernels, the texture of the husk, and the delicate strands of silk provide rich material for photographers seeking to capture the beauty of everyday objects. Painters have depicted corn in works ranging from realistic still lifes to abstract compositions. The American regionalist painters of the early 20th century often included cornfields and corn harvests in their depictions of rural life, using corn as a symbol of abundance, hard work, and the enduring connection between people and the land. In the world of design, corn motifs have been used in architecture, textiles, pottery, and jewelry. The corn ear, with its rows of kernels and its graceful, tapered shape, is a naturally beautiful form that lends itself to decorative applications. In some architectural traditions, corn ears and corn husks have been carved into column capitals, moldings, and other ornamental elements, celebrating the importance of corn to the culture and economy of the region. Sweet corn has also played a role in the world of records and competitions. The world's largest ear of sweet corn, the tallest sweet corn plant, the fastest corn-eating competitor, these records and competitions celebrate the human fascination with extremes and the playful spirit of agricultural communities. Corn-eating contests, in particular, have become popular spectacles at fairs and festivals around the world. Competitors race to consume as many ears of sweet corn as possible within a set time limit, using a variety of techniques. Some nibble in neat rows, while others attack the ear in a typewriter-like fashion, moving systematically from one end to the other. These contests are light-hearted and entertaining, but they also reflect the deep cultural affection for sweet corn and the communal joy of the harvest season. Let us return to science for a moment and discuss some of the latest research findings related to sweet corn. Recent studies have investigated the potential of sweet corn extracts as natural food preservatives. The antioxidant compounds in sweet corn, including phenolic acids and flavonoids, have been shown to inhibit the oxidation of fats and oils, which is one of the main causes of food spoilage and off flavors. The use of natural antioxidants derived from sweet corn could reduce the need for synthetic preservatives in processed foods, aligning with consumer demand for cleaner, more natural ingredient lists. Other researchers have explored the use of sweet corn silk extract as a functional ingredient in beverages and supplements. The diuretic, antioxidant, and anti-inflammatory properties of corn silk make it a promising candidate for inclusion in health-promoting products. Some companies have already begun marketing corn silk tea and corn silk extract supplements, though the scientific evidence supporting their health claims is still limited and more research is needed. The gut microbiome effects of sweet corn fiber are another active area of research. Studies using advanced sequencing technologies have revealed that the fiber and resistant starch in sweet corn can promote the growth of specific beneficial bacterial species in the gut, including Bifidobacterium and Lactobacillus. These bacteria produce short-chain fatty acids, including butyrate, propionate, and acetate, which have been shown to have anti-inflammatory, anti-cancer, and metabolic benefits. The relationship between sweet corn consumption and cognitive health is an emerging area of interest. Some preliminary studies have suggested that the antioxidants in sweet corn, particularly lutein and zeaxanthin, may accumulate in brain tissue, where they could help to protect against oxidative damage and inflammation that contribute to cognitive decline and neurodegenerative diseases. While this research is still in its early stages, it adds to the growing body of evidence that a diet rich in antioxidant-containing foods may support brain health and cognitive function throughout the lifespan. Research into the allergenic properties of sweet corn is also ongoing. While corn allergies are relatively rare compared to allergies to foods such as peanuts, milk, and wheat, they do occur and can range from mild to severe. Scientists are working to identify the specific proteins in corn that trigger allergic reactions and to develop diagnostic tools that can accurately identify individuals with corn allergies. This research is important for improving the safety and quality of life of individuals who are allergic to corn. The potential role of sweet corn in sustainable biofuel production is another area of research. While most biofuel corn is field corn rather than sweet corn, the byproducts of sweet corn processing, including cobs, husks, and stalks, represent a potential feedstock for cellulosic ethanol production. Cellulosic ethanol is produced by breaking down the cellulose in plant material into sugars and then fermenting those sugars into ethanol. Because it uses agricultural waste rather than food crops as its raw material, cellulosic ethanol is considered a more sustainable alternative to conventional corn-based ethanol. Let us now bring our documentary to its conclusion by reflecting on the place of sweet corn in the broader context of human food systems and the human experience. Sweet corn is a food that embodies some of the most fundamental themes of the human story: our relationship with the natural world, our capacity for innovation and improvement, our desire for nourishment and pleasure, and our ability to build community and culture around the simple act of sharing a meal. From its origins as a chance mutation in an ancient grain, sweet corn has been shaped by human hands and human ingenuity into one of the most popular and beloved foods on earth. It has traveled from the fields of ancient Mesoamerica to dinner tables around the world. It has been cultivated by indigenous farmers, studied by scientists, improved by breeders, and enjoyed by billions of people. The story of sweet corn is a story of partnership between humans and nature. We did not create sweet corn, nature did through the random occurrence of a genetic mutation. But we recognized its value, we nurtured it, we improved it, and we spread it across the globe. In doing so, we transformed a humble grass into a food that brings joy, nourishment, and connection to people everywhere. Sweet corn reminds us that the simplest foods are often the most profound. A perfectly cooked ear of sweet corn, eaten on a warm summer evening, is one of life's great pleasures, It requires no elaborate preparation, no expensive ingredients, no culinary expertise. It is food in its purest form, natural, wholesome, and deeply satisfying. As we look to the future, the story of sweet corn is far from over. New varieties with enhanced flavor, nutrition, and sustainability are being developed. New technologies are making it possible to grow sweet corn more efficiently and with less environmental impact. New culinary innovations are finding ever more creative ways to enjoy this versatile food, and new scientific discoveries are revealing ever more reasons to appreciate the health benefits of sweet corn. But perhaps the most important thing about sweet corn is not what it does for our bodies or our taste buds, it is what it does for our souls. Sweet corn connects us to the earth, to the seasons, to our communities, and to each other. It is a food that brings people together at the dinner table, at the cookout, at the farmer's market, at the festival. It is a food that creates memories, the memory of your first bite of corn on the cob as a child, the memory of shucking corn with your family on a summer afternoon, the memory of the sweet, smoky aroma of corn roasting over an open flame. These memories and the experiences that create them are the true gift of sweet corn. They are what makes sweet corn more than just a food, they make it a part of who we are. As we conclude this documentary, let us take one final look at the extraordinary numbers that tell the story of sweet corn's place in the world. Millions of acres of sweet corn are planted each year around the globe. Billions of ears of sweet corn are consumed annually. The sweet corn industry supports hundreds of thousands of jobs, from farmers and farm workers to processing plant employees, truck drivers, grocery store workers, and food service staff. The economic impact of sweet corn is measured in the billions, and its nutritional impact is measured in the health and well-being of millions of people. But numbers alone cannot capture the full significance of sweet corn. The significance of sweet corn lies in the joy it brings, the traditions it sustains, the communities it nourishes, and the connections it creates. It lies in the smile of a child eating corn on the cob for the first time. It lies in the satisfaction of a farmer surveying a field of tall, healthy corn plants. It lies in the warmth of a family gathered around a table, sharing a meal that includes the golden kernels of sweet corn. Sweet corn is a gift from the past, from the ancient farmers who first domesticated maize, from the indigenous peoples who discovered and cultivated the sweet mutation, from the breeders and scientists who have worked for generations to improve it. And it is a gift to the future, a sustainable, nutritious, versatile food that will continue to nourish and delight people for generations to come. The next time you see sweet corn at the grocery store, at the farmer's market, in your garden, or on your plate, take a moment to appreciate the incredible journey that brought it to you. Think of the thousands of years of history, the millions of hours of labor, the countless acts of care and cultivation that are embodied in every ear. And then take a bite and savor the sweetness, not just the sweetness of the corn, but the sweetness of the story behind it, because sweet corn is not just a food. It is a miracle of nature, a masterpiece of human ingenuity, and a testament to the enduring partnership between people and the plants that sustain them. It is a story that began thousands of years ago and that continues to unfold with every seed that is planted, every ear that is harvested, and every kernel that is eaten. This is the story of sweet corn, and it is far from over. Thank you for joining us on this remarkable journey. We hope that this documentary has given you a new appreciation for one of the world's most beloved foods, a food that is simple and complex, ancient and modern, humble and extraordinary. We hope that the next time you eat sweet corn, you will think of the incredible history, the fascinating science, and the dedicated people behind every golden kernel. And we hope that you will share this story with others, because the story of sweet corn is a story that deserves to be told. From the ancient fields of Mesoamerica to the dinner tables of the world, from a wild grass to a global treasure, sweet corn has been on an extraordinary journey, and every time you take a bite, you become a part of that journey. So here is to sweet corn, to its past, its present, and its future. May it continue to nourish, delight, and bring people together for thousands of years to come. Thank you for watching. Please subscribe to our channel for more history videos in the future, and let us know in the comments what you found most surprising or interesting about the story of sweet corn. Until next time, enjoy your corn.